My name is Jeremy Ryder. I am from Network Solutions. We're the vendor that installed the wireless this year and have for, gosh, past I don't know how many years. 6 years? We've been doing it a long time. The fun part this year is we get to dive into, kind of pull back the curtain of exactly what we're seeing from a wireless performance standpoint. But before we get into DNA Center, I want to take a step back. NSI did a roadshow back in April timeframe to kind of go through this DNA vision. Cisco has come out and released DNA, and it opens up a whole can of worms on what does DNA actually mean, what does it look like, how do I operate it, so on and so forth. And one of the reasons we did that is because I really do feel strongly that we are looking at a time of change from a networking perspective. We've done a lot of box-by-box configuration for a long time, and yet over in the corner over here, we've talked about software-defined networking as well. And it seems like this wonderful thing we'll get to, but I never really see it materialize. Software-defined networking promises a lot of things, and it also is categorized as a lot of different things. So I'm going to start out with a question to you guys, and I'm looking for volunteers to respond. What would you say software-defined networking is? I told you it's a mystery. Software-defined networking.
How do you copy and paste, right?
You can copy and paste. You can script. A lot of what I see and a lot of the answers that I get have to do with automation, have to do with making my network plug and play, where it's almost like an electrical outlet. It'll solve problems for me. It'll do this and that. And the answer is it can be all those things. It's software defined. We live in the age of software where I can order a taxi through Lyft or Uber. I can book a plane flight from my phone. I can order a car. I saw a commercial the other day, Carvana, I think. And I want this color, and I want all-wheel drive, and I want a 5-speed, and I want it Tuesday. And they'll drive it right out to you, and you got your new car, right? Because some developer, some programmer thought, hey, this is something I'd like to do, and they created it. And that's, to me, where we're going from a software-defined perspective. But it's kind of been vaporware all along, because I've never had a product to really rely on to start building those software applications from. Cisco's seen this, and candidly, I just gave some examples of where software has invaded our lives. The networking industry might be a little bit behind on this utilization of software, but we're catching up, and we're catching up fast. Cisco built DNA Center to fill that gap. I said it's vaporware. It hasn't appeared. I've been hearing about it since 2012. Now we have a product. Now we have something to build off of. Now we have something where we can start to look at analytics, data that I'm getting from my network, automatically configure things. And today, or over the past few days, I should say, we've been working on building out the wireless network here, using Assurance or using DNA Center. And then we'll dive into a little bit more some of the reporting that we can get out of it and the analytics that we can get out of it as well. So we'll look at things like network health, which you might have been exposed to before, right? Software packages have been written, SolarWinds, Cisco Prime, PRTG. I'm seeing nodding heads. You guys probably leverage some of these products. Meraki took a step into the software-defined game already, where I've got cloud management where my dashboard allows me to configure these things instead of being command line based and typing away on each of those boxes. And I talked to somebody earlier and they said, yeah, I love my Meraki network. Well, why? It's not because it's got more horsepower or can push more packets than another switch. It can't. But it's got a software package tied to it, that dashboard that allows me to easily configure and monitor, make changes much faster than I used to be able to. That's the power of software, and we're taking it a step further. So we'll look at network health, some of those dashboards we're accustomed to. Taking it a step further, though, we're also going to look at client health. how many reporting software products have you seen that say, here's how your network's performing from the client's perspective? So much I look at the box, what's my CPU utilization? Well, what does Dave over in HR care about the CPU utilization on the box? He doesn't. He just needs to get to the Google Sheet that he's using, and if that comes through in a good amount of time, then as far as he's concerned, the network's good. If it doesn't, but maybe my CPU utilization is low, he doesn't care that the network looks good. He just needs his Google Sheet to be accessible in a quick amount of time. So client health to me is a new analytic and analysis that we can perform and in grading out our networks and how they're performing. We'll look at application health, getting back to Google Sheets or Office 365 or all these applications that are running on top of our network. Again, the network may look great, may have no disk cards on my links, but for some reason that application is not performing. We can look at that. Just basics from a design perspective. I'm all for standardization because that eliminates a lot of the errors and more human errors, I suppose. So how many, let's see, who do we have in the room today? Do we have network operators, managers? You're in charge of the day-to-day configuration and operation. Raise the hands. Okay, we got a few. Maybe network or IT managers, technology managers. We have some of those. Okay. And what else? Anything else that I'm missing? No? So for those of you that are in charge of configuration, I guess, I imagine you've probably standardized on your DHCP servers that you're using. They're pretty consistent from one subnet to the next, yes? You've probably standardized on the DNS servers that you're using, yes? Have you standardized on the SNMP strings on every box? I start to see some no's. Have you standardized on the syslog? So the reporting that you're doing is getting to the same database, maybe? We can go into NTP, NetFlow, right? The list goes on. One of the things that we can start with in DNA Center from a standardization perspective is just the overall design. What do those things need to be? My DNS, my DHCP, my NTP, my syslog, NetFlow collectors. We can define all those so they're consistent across the board. Or maybe they need to be different from one site to the next. Since we have DNA Center, which becomes our centralized controller for all of our switches, for all of our access points, our wireless controllers, our routers, we can set a policy, set a standard, and we know that that's applied consistently across the board. So just in standardization, there's a lot of power here. As we go through this, just keep in mind a lot of the, this is a platform that I think that will continue to be expanded upon, right? So from that software-defined perspective, I can do consistent configuration. I can do that today. I can look at a lot of the analytics. I can do that today. But this platform is going to continue to grow and evolve with the demands that we get back from customers like you and the challenges that you face. So at this point, I'll turn it over to Brent. Brent is from Cisco and has spent quite a bit of time, I think, with DNA Center over the past year or so. And let's dive into this and see what we can get out of it.
So as he mentioned, NSI has been hooking together the Wi-Fi for HECC for 6 years now. And the short of the version is it's done in a quick fashion. I mean, if you guys look around, you'll see APs taped to walls. You'll see them, stashed everywhere because the wireless doesn't already exist. So they come in. Chris and John do an awesome job coming in, putting in for 2 days. They set it all up, hook everything up, and they do it. As far as I know, I can see from here, we're seeing really good results for the 1,200 clients. I think last I looked, we had online. But the thing is, you're quick in, you're quick out. You don't have time to set up the stuff, and it's already existing infrastructure. I don't have the budget to replace 60-some APs, change out wireless LAN controllers, all that stuff. I have an existing infrastructure that we're trying to figure out how can we improve without overhauling everything. So what we did was we brought in DNA Center to try to supplement the system that NSI already had running. So what that means is we brought it in and we did it, I brought in my lab gear. So it was one box, one ice server, very simple setup. And I also set it up in such a way that it is simple to do, or in that case, simple to undo, in the sense that we wanted to make sure that we didn't have any impact on the user experience. So when I connected up to the existing NSI Connect system, it was basically 2-3 clicks. We set up a few certificates, and then we're off and running. Very low impact to the customer, in this case NSI, so we didn't have to worry about large, massive changes. Now, what he was talking about as far as standardization, design policies like that, those are options you have to go down that road. It's just basically you can choose how far you want to go down the path of, taking over the system with DNA Center. In this case, our goal here was to make sure the wireless experience was the best it could. That's it. That was my goal. I want to make sure that we could track down any issues because we only have 3 days to fix them, and you guys are going to notice in about an hour. So with 64 APs, 3 guys, we don't have a lot of time to track that down. So we want to make sure that if anything went wrong, we could track it down as quickly as possible. So in this existing setup, just for you guys, for what HECC has, it is 2 5520s in HA. We've got Meraki firewalls, MX250s. We've got Meraki switches in the core. And then we've got 60 some odd 3702, so wave 1 APs. So we're not even using the latest and greatest generation of APs. We're able to get a lot of data out of that the wave 1 APs. Now I do have a 4800 here because I got some new tricks that are pretty cool you can do with the wave 2 APs you can't do with the wave 1s. So I'll show you those difference, but you can get a lot of the value out of the existing, you guys have been using those APs for what, 4 or 5 years now? Yeah. So this is not we need to overhaul the network to get value out of this stuff, right? We're trying to just think of how can we improve the existing stuff that's already out there. So from that point of view, we came in, had a discussion, and like I said, our goal here was to be as least impactful as possible, which a lot of, with any technology that people are unfamiliar with, you don't want to say, oh yeah, we're just going to reconfigure everything. It's no big deal. It's 100 switches of reconfiguring, right? We wanted to make sure that we're going to work our way into this. So we started out with, basically I set up a site called Indianapolis, created a venue called HECC, and then we put in the different floors we had. So I loaded in the floor maps. Basically, it's as simple as just coming in here, adding a floor, editing the floor. I load the map, I give it dimensions, and then I've got sites and floors I can start working off of. So it makes it really easy to push policies very easily and very quickly. So you're not having to say APs 10 through 16. You're going to say, no, I want to push a policy to conference center, or I want to push a policy to Grand Hall first floor. I'm not thinking in a model by model way. I'm thinking in a site by site way to really improve that consistency and ease of use. Now you can see here, I just clicked on it. This is talking to CMX, and already I have all the APs dropped in here, and I can very quickly, down the road, I'll talk to this about a little later. It makes it very easy for me to see what APs are having issues and which ones aren't. Green's good, orange is fair, and red's bad. So I probably want to take a quick look at that red one at some point. So that was the first thing we did. We did the AP deployments here on Monday. I then dropped in the APs where they belonged because I'd already assigned them. Very quick and very easy. But now I've got some context and something I can understand when I'm looking at problems. I understand where the problems are and how they're impacting people. It really makes it human readable rather than a screen full of just lots of numbers. So once we put in the maps, we put in where the APs go. We then did a provision. Now there's different levels of provisioning. Like I said, we can take full control of it. We can say DNA Center now has full ownership of all the switches, the WLCs. It's going to set the policy and enforce the policy. Now because I brought in lab gear, which isn't always the shiniest and the newest, we want to make sure that if anything happened to my old servers, that nothing impacted, so we connected up in a low impact way. So all I had to do is come down here to the WLC primary, select it, and then say add device to site. When doing that, all it does is it communicates to the WLC, sets up an SNMP username password, it passes certificates, a few very low touch pieces of information. Nothing major, no reconfiguration, no taking control. That's a complete option, but we chose not to do that because it's a 3-day event. So the nice thing is as soon as I added the WLC, it then brought in all of the APs we've got in the system. Quick, easy, didn't have to fight to get them in, they came in automatically. From that point of view, it's much easier than all I had to do was say, okay, look at that map I brought in. I selected 2, 3, 4 APs, and then all you have to do is say assign to site. And then you can choose what floors, buildings, whatever you want it to go into. So what that does, that communicates to ICE, telling ICE where it is. It talks to WLC, telling it where it is. Talks to CMX, telling it where it is. And it keeps everything. So instead of having to go to all my different systems and make sure that they're all done the same, I did it in one place and it pushed the configurations everywhere. Very nice and very easy. And again, this is not in a fabric mode. This is not an SDA. This is in a standard local WLC mode that most people are running. The same also apply to Flex Connect, which is probably the other way a lot of people are connecting up. And I should probably state, so I'm going with no slides. We're just doing live. So if you have any questions, please just chime in, jump in, ask the questions. Let's have a conversation around it, because there is so much here I get kind of geeked out on that I want to make sure you got your questions are being answered. So the other thing all I have to do is then say network telemetry. I can go in here to the WLC, and I can set how much telemetry do I want to come across. You typically will do that with WLCs and routers. Now, because we were using Meraki wired switching, I don't have that option, but for the WLC, I can go in here, set the visibility, and that starts bringing over next generation telemetry pieces. So rather than the SNMP, slow, not very much information, with it running AirOS, I think 8.5, 8.6, and up, we start getting more and more functionality to where we're running 8.8, where we have constant telemetry coming in, live telemetry. We're not having to wait, it's instantaneous. So that's the other nice thing, we're modernizing the information we're getting. So that's kind of how we set it up. Did I miss anything on the configuration that I'm thinking of? So it's, it did, I think I spent roughly 2 hours doing all the configurations for HECC. I mean, that's pretty quick when you did it. Figure 60 some APs, 4 different floors, CMX configuration, all that. It was about 2 hours. All said and done, just for I've spent less than 16 hours probably on this entire project from start to finish, excluding the 4-hour update I had in the middle of the day. So it's a pretty quick, easy process.
The only other thing we talked about going over was maybe network settings and the profiles.
Oh.
We didn't use them.
Yep.
But at least to show from a standardization
Yep.
perspective what's allowed in the system.
So once I created the site, I put in the maps. You can then go into network settings, and you can standardize AAA servers. Set up your ICE, DHCP, all those different information, and then you have the option of pushing that down to a site. So if you say, I want these settings, I can push them onto those 6 or 7 APs or those 10 switches that are assigned to each floor. So if you've got building by building, floor by floor, city by city, different settings, you can push them, and you know that they're all getting pushed to the right places. No accidental, oh shoot, I just sent the wrong subnet gateway to the wrong city, and now I've lost connectivity, and how do I get it back? Crap. It's going to be a very consistent way of doing it. We can even set up wireless settings where we did this. We actually pulled it out. Again, for consistency's sake, we wanted to keep for first year doing it, we want to make it as simple as possible. But what I did do was set up 2 wireless profiles. So here at HECC, we run a 5 gigahertz, which is HECC, and then we run a 2.4 frequency for those legacy devices, because we want most people to be on the 5 gigahertz due to interference issues. That's why it's just called HECC. So we set those up, and then literally it will push it down to, you say add, it will push it down to the WLC. It's really, and the nice thing is, it does it in a non-destructive way. So normally your WLANs are, 1, 2, 3, 4. It starts at like 17. So that way anything gets added doesn't overwrite anything. When you remove them, it doesn't affect anything you've done manually. So you can mix and match your traditional manual way of doing things and the DNA center pieces for consistency. You don't have to throw out everything you've already done just to start getting advantages in the system.
You can also spin up different wireless networks based upon each location, right? So the hierarchical nature of DNA is by site. So if you've got a group of SSIDs that you want to send to elementary schools, maybe a different group that goes to middle schools, high school, maybe the admin building is different, so on and so forth. It really is built to look at the network more from a hierarchical perspective than just, hey, we need some blocks over here.
So in this case, I'd applied the HECC profile to the 7 sites, the 7 floor, to the master site, the building, and then I applied it to also the floors inside of that. So basically, anything in this building was going to get that same profile, because we want, in this case, the same thing everywhere. We don't have a need for difference, but it's very easy to do. It's just literally changing a setting.
So you went through the design and you went even to provision. How did you get all of those APs into the provision tab?
So
you had a huge list of them.
So the APs came in as soon as I connected up to the WLC, and I said connect to the WLC, which it had the credentials, set up the certificates. As soon as that happened, it pulled all of the other APs. It said, WLC, what APs do you own? And let me look at them. That's all I had to do. I didn't have to go for a discovery. The only thing I had to discover was the WLC originally, which there is a discovery tab. You put in you can do it through CDP, you can do it through IP range. It's very simple to do, and it'll just show up on the list with some pre-added credentials I already threw in there. So it's a really easy system to get stuff to pop up. And again, just because you have it in your list doesn't mean you've taken control. You have different settings, levels of control you can take. So that's where we left it off last night. So last night, we had the APs up and running, we had the connections made, and we had 8 clients. We had 8 clients, yep.
4 of us in a room, each with a laptop and a phone.
So I'm going to pull up the assurance. So assurance is our way of looking at it, but part of the reason why I don't have any slides is I want you guys, honestly, we're not the only ones doing this. The reality is, this is the way industry is going. And it's about thinking differently. I mean, I'm thinking Apple may come after me for saying that. But the way you come to conclusions gets a lot simpler, and the way you'll troubleshoot things becomes a lot different when you have tools like this to dig into things quickly. So we went home, came back in the morning. So this is a 24-hour view. So we've got the network devices, of which we have 66 APs, 1 controller, and then we had wireless clients. So as a network whole, we were actually sitting pretty darn good on the network health. This is about 9 a.m. when you guys all started coming in. And our network health went down. And then our wireless clients, they were not that great. But as soon as people started coming in, our wireless clients went up. It's a little counterintuitive, right? Well, what it is the law of averages. When you go from 8 clients, and I think we were sitting in a room that didn't have good coverage, so we're going to have some pretty bad percentages. But our network health is going to be good because our utilization is next to nothing. Well, when you guys started coming in, we have 1,000 clients. Our AP started taking a load. They started getting utilization. There started being interference. But our wireless health actually improved. Our wireless health is up at 85%. So those are metrics that are in the system, for for signal noise ratios, and interference, and air quality, and all these different things. We apply a health score on it. So what this tells me is, even though the network's getting loaded down, we're getting heavier AP usage, we're getting different interference, we're getting all kinds of beacons and all that stuff. At the end of the day, our clients are healthy, and that's the important piece. We shouldn't get bogged down always in what the APs are saying. It's about making sure all of your devices are healthy and happy. That's the important part. If we have a bogged down AP, that, right now, I can tell you right now, that AP sitting in this room, it's probably sitting in a fair, and I'll look at it in just a minute. But if I look at all your laptops, you're going to have a pretty darn good score. So we'll go ahead and start looking at the network devices real quick. So I can mouse over this, and it's going to tell me I've got 32 healthy, 34 poor, fair, or no data. So so half our APs are sitting really nice. They're sitting not underutilized. They're just sitting about right. We're going to go ahead and open this up. And then I can see here the wireless LAN controller is 100%, no problems. We're sitting there. That means we don't have any memory issues, buffering issues. We don't have latency issues. It's sitting right. So we've got a 5520, and we've got no issues where we're overloading that controller. From an AP point of view, we've got half of them sitting pretty good. We've got 26 of them which have a mediocre score, and then we've got 4 of them with a low score. So that's going to get my attention right off the bat. So, and it's going to say the reason why we've got low scores is high noise, high interference, and high radio utilization. No kidding, right? You got 1,100 users, 60 clients, and we've got APs taped to the walls. It's going to happen. So let's go ahead and click on this. So rather than having to go into another place, we can click on and just start diving down. Rather than having to go, okay, that's in the WLC, but this is over on this tab, and I need to go check my wired client logs, I need to go look over here, I can just keep driving down into this system and be able to get to a resolution quickly. So we can take a quick look here. So our CPU, memory, all that's good. So we've got 3 radios at high utilization, 2 with high interference, and 2 with some noise issues, but nothing too bad. So I can quickly go ahead and look at radio utilization. And we can click at the poor ones. And here's my 3 APs that have high radio utilization. I can quickly go in here, and it will say that they've got a score of 1. And if I mouse over it, hover over it, it will say I'm at 84% utilization on radio 1. So my 2.4 is being maxed out on this AP. How long would it take to dig into that in traditional systems? Right? It's quick, it's easy, and it's intuitive. Right? It guides you where you need to put your attention. Rather than getting bogged down in an issue that sometimes can be misleading or not very important, it directs you to the most critical things to worry about first. So I've got 3. So I'm going to go ahead and click on this AP. Open up AP 36. And now the cool thing is, here's the last 24 hours of visibility. So how many calls have you guys gotten or heard of where someone says, my wireless was really bad about 4 hours ago? And you go, that's great, is it good now? Yep. All right, call me back when it's bad again. Right? Or if it's the owner of the company, you go, all right, let me dig into it. And you go, how in the heck am I going to troubleshoot something that happened 4 hours ago? So the nice thing is this has 14 days of records where it records all the telemetry we've got. So you can go back and troubleshoot and find these problems even though they happened in the past. So I can go along here, mouse over things, and as you see here, as what's changing on the bottom is it's actually showing me what was happening. So back here when it dropped to red, as I mouse over it, my radio utilization spiked. And then it went back to not too bad. So what if that person called during that 10-minute window where we had high utilization? So they called during a 10-minute window of bad traffic, but really the issue is you could spend the next, if you got on any time in the next hour, you're going to find no issues. But here you can say, look, here's the issue. We saw this happened to multiple clients. This was an AP thing. What can we do to resolve that issue, long term? But it's something that was easy to find on the way. Yeah. Yeah.
That graph, you actually tell that the channel utilization was high all times, even midnight. So you're like, okay, we're not even using the number, channel utilization's high. So they can check where that utilization's coming from.
Yeah. And then the other thing we can do is it will do suggestions where it'll say, hey, this is what we're seeing. The 2.4 radio is over the threshold, and it even tells you it's impacting one client. So it'll say it's impacting one client, 5 clients, 10 clients. It'll tell you how severe this issue is. And then it'll also say, hey, here are some ideas you might want to look at. So TAC has come up with a list of things of commonly seen problems and commonly seen things that you should look at. So we can migrate clients to 5 gigahertz, which is why we've got the HECC that doesn't use 2.4. We can disable 2.4 to do colocation. We can do all kinds of stuff. We can even have it run commands from this troubleshooting area. So you can go, you know what, let's go ahead and run the clean air. Let's go ahead and see if there's anything that's causing some of the interference. Let's see what the answer is. So rather than having to drop out of the WLC, go into the command line, remember what the commands are. I just in 2 seconds clicked it, and we've got a lot of Bluetooth traffic happening on that AP from clean air. We've got a lot of Bluetooth discovery devices. And unfortunately, Bluetooth on 2.4, nothing we can do about it. We have to accept it. But now we know there's a good chance more of our issues are coming from Bluetooth problems. And now rather than spending time troubleshooting weird things or client issues or drivers, here's an area you might want to be looking at going into and really focus on your troubleshooting time, cutting down the time you're trying to go from I've got a wireless issue to it's here at this AP to oh, we have some interference, we should probably be looking at that closer. In 5 minutes, we were able to really narrow it down where it's much more difficult to do. And the cool thing is you can do that historically. You don't have to be on site at that moment with a Wireshark trying to figure things out. Along some other troubleshooting things to help with, we have the topology. So I have AP36 sitting right here. And I can see I've got 7 2.4 clients and 45 5 gigahertz clients. So it's pretty busy anyways, but 7 clients are that 2.4 radio is the one with the issues, not the radio with not the 5 gigahertz with the 50-some clients, right? So it's about spending where's your time optimized, troubleshooting, trying to find the problems and improving customer experience, not about, just because I've got a bad number, I've got to do something about it. Take a look at the overall holistic picture. If the clients are happy, if the apps are happy, if everything's running right, sometimes it's just this is the way it is. And other times, you need to dig into it and find out you've got a Bluetooth. We've got, who knows, maybe someone's got a display of 10 different Bluetooth devices sitting right there.
Brent, I'd add to that, those aren't just summary numbers. You can dive in to see exactly who those clients are.
So I can do view client device list, and here's all devices that are on that thing. So now we're NSI is very nice, HECC's very nice in the sense that it's open Wi-Fi. That means that there's no web auth, there's no passwords. We've got no way of knowing who any of your devices are, but we're still getting value out of it. So even though it's a completely BYOD system, we're still able to identify devices, we're still able to put scores on them, we're still able to follow them around. I'm just going to randomly click on one of these devices just to prove my point, and I can see they were on for a bit here, and they've been on back here. And I can take a look at DesktopTCO, whatever it is, and scroll along here, 240 MIP, 400 MIP, I can see their data rate, their transmit rates, what APs are connected to, and then down here I even have major events. I can see their onboarding. So I can take a look at what events they've got going on here and see, oh, they had an onboarding event. Let's go ahead and take a look at that. So when they've got questions about I'm having slow onboarding issues, I can go in and say, let's take a look at the whole chain of events on how they got onboarded. So you can say association start to association done, mobility, running. And if I look at some other clients, you'll see some that are roaming like crazy as people walk around, right? Hopping from AP to AP to AP. And other ones, like this one seems to be pretty stationary, which makes sense because it's called desktop. I'm assuming it's not going to be doing too much roaming. So really trying to help out that customer. I mean, to me, that's where I get the coolest thing out, because I did, I worked for Purdue. I did Frontline help desk, and 80% of my issues were wireless issues. Wired's a fairly, it's on or off, yes or no. Wireless is, are you standing by a fish tank? Is there radar airport radar going by? All kinds of issues could be happening that are just so hard to know day to day. I saw one where someone didn't like the blue light on the AP, so they just stuck a box up there. Well, the box was one of those stupid insulated boxes with a little aluminum foil on the inside for like what was it, Hello Fresh, one of those. Well, that killed the AP. You know, how's an IT guy supposed to figure that one out? You know, without walking out there. And the nice thing is, on top of that, is working this in reverse a little bit. So even though we've got 1,043 clients, I can narrow down and take a look, say that AP36 is 14 clients on it, and then I can quickly figure out if this is an AP issue or a client issue. If I've got 13 of my 14 devices are happy with good scores on that AP, I'm betting it's not an AP issue. If all of my clients who are connected up to AP have low scores, maybe I have an AP issue and I need to investigate the physical aspect of that.
Can you go back and show
Yeah.
me one more time?
Which,
The onboarding process.
yeah. So I'll just pick a,
Pick somebody else.
I'm assuming an iPhone's going to roam around a little bit. So there's the onboarding where it's going to go from the client to the SSID.
I was going to say, this graph is what I wanted to highlight because they're already showing you issues. I mean, you can look at this and say, okay, my wireless controller, good. My AP, we got some issues going over here. This is the SSID they're connecting on. We talked about 2.4. That's what it's on. And so already you're starting to get an indication. Sometimes I'll look at these and see green, 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 red. Well, obviously, I need to look at that AP. It's underperforming for whatever number of clients it's trying to service. So just that simple graph, I think, elevates our ability to troubleshoot in a quick manner and an intelligent manner, where you're driving down to the actual problem that's there. So I want to go back over that.
And then, like I said, because it's all being recorded, we have Event Viewer, just like in Windows, where we can go in and say, oh, look, this person's been roaming around. They've roamed from 36 to 26 to 27 to 23. They've hit almost half our APs, it seems like, as they've been walking around. But then we can pick out problems. Okay, they had an incomplete onboarding. What's up with that? You know, we can look at time, how long it takes. You know, okay, they've been doing a lot of walking. You know, but we have all that record, so you can really understand what's been happening and go back and troubleshoot their problems. Like I said, and then we have DCP information. We score a lot of stuff. And then we also have connectivity things where we can go and take a look at, you know, their transmit, their receive, their DNS requests. We can take a look at some of this other stuff and seeing what's going on. Are they having some other issues? Maybe it's client related with some bugs with, I've not that I've experienced too much of them, but Chromebooks. You know, I've heard those have got some weird issues sometimes. Being able to then go ahead and sort by, you know, oh look, this is a Chromebook. We can kind of tell it's got a bad driver because of something. You know, things you kind of learn about, but it really makes it graphical rather than being some random number. The overall client dashboard, again, how do you drill down on this quickly? So we got 90% in good shape, we got 10% in fair shape, and that's on the HECC 2.4. I'm just going to go ahead and do all SSIDs so we can have an overall system view. You know, so the nice thing is we can go and look, you know, our onboarding times are sub-second. You know, I'm pretty happy, or sub-2 second. I'm pretty darn happy with our onboarding times. We've got no issues there. Our SSI, you know, we've got a few sitting out there in Neg 72, but most of them are pretty good. I'm pretty okay with how this is working. You know, we can take a look and drill down on where our clients are sitting, what SSIDs they're on, you know, what band they're on. We can really understand. And like I said, we've been gathering data now for, roughly 6-7 hours, and I can already tell you what APs probably need to get moved. I can already tell you, I think John and I were talking. There's a few rooms that probably could get another AP tossed at them next year. But this is stuff that, you know, we were able to figure out in hours. And we can dig into client devices. I'm going to find I'm going to look for an iOS device that's on 10 or greater. There we go. So one of the cool things is all iOS devices in version 10 or greater actually has code in the, Apple's put code in the OS that communicates with DNA Center for us. It's something part of the Apple-Cisco relationship that the Apple device then becomes a sensor for us. Rather than having to depend on just the AP's point of view in the world, we can ask the iOS device, why are you doing this? and it generally will tell us. So in this case, I can see which ones it's seeing. If it can see multiple APs, it'll tell me what APs the iOS device can see. And then it'll also tell me why it moved APs or it failed out. So it'll actually say back, I roamed because of this. So rather than having to depend on your AP saying, oh, I'm good, I'm strong, I'm great, don't worry about me, it's not my problem, the Apple device can say, no, I'm not seeing it right, so I'm going to connect up to this one instead, even though it's the weaker signal. So you can and even though it's just Apple devices, the fact is rising tide raises all boats. A lot of problems are going to be the same problem for an Apple device as they are for an Android device or a Mac or a PC. So it really helps us understand what's going on out there in the system. So it's a feature. I think it's a really useful tool.
Who's got an Apple device with them today? We've got
Yeah.
a few sensors in the room.
Yeah.
Probably enough to get some feedback on how the wireless looks in it.
And this is going to date me. I remember way back when we had radio failures. Now this is going back 18 years. We were having radio failures. The AP said, oh yeah, my radio's great. But when we had someone with a laptop walking around, no signal. Just wasn't coming out. So when the Apple device can able to report back and give you the other side of the story, 2 sides to every story, now we've got this whole story. So the other thing we're adding in is the ability to have sensor tests ran. So we've got Mac version, this is on Mojave, we've got some High Sierras, we've got some old 10s. What's our reference point when we're doing wireless testing? So we can take existing APs and turn them into sensors, and we also now have small sensors that are USB powered or PoE powered that you can use as a reference sensor. So rather than having to wonder, is this a client issue? Is this a version issue? We have a referencing to say, no, this is what's actually happening. So then we can go in and we can even program sensor tests. So I've got 2 sensors programmed into the system. And you can see here, and again, I've been playing with this, I haven't spent a ton of time on it. But the fact of the matter is, I've got every half hour, I've got running an onboarding test, a DHCP test, SLA test, DNS, speed, and web server test. And I have it running them on every half hour. I've got running on 2 devices. One, I've got one of these sitting somewhere out there in the hall. Probably should find that before I go home. And I've got a 2800 sitting back there in the corner. They're both running the same tests, and they're both able to run them every half hour. Cool thing is so right now I can see the onboarding test, DHCP, so I'm having some issues with my SLA test, but everything else is passing pretty well. Like I said, you can do it on, and I'm running it on both the 5 gigahertz and the 2.4 on both SSIDs. So what we can do is go into dashboards, sensors. It'll give you summaries of what tests are happening. 9% of tests have failed. We can dig into, scroll through. We can look at some more DHCP stuff. We can look at DNS, and we can understand what's happening with our network rather than having to, get out there and run the test. Or what you can do is if you have new AP deployments, you can set these out there and make sure when you've done a new flow or you've done replacements that you are getting a reference test to go off of rather than just putting them up there and hoping, oh yeah, I think I got that right, and then come back, once the complaints start rolling in. Be proactive. Make sure the customers, the users, the students stay happy. That to me, that's the name of the game. It's, we all can get a system up and running, but if we can be proactive and fix things before they become an issue. If it takes someone 10 days to get fed up or 2 days to get fed up that their app's not running right or the wireless sucks in this room, if you can be proactive and say, I am seeing this in a couple hours, I already know I have to go fix that, we're going to take care of this, and we're not even going to get the call. How much time does that save? And then for when you do have those bad issues, I'm going to dig into, like I said, I've got 4800. So all this information you've seen so far is coming out of Wave 1 APs. So nothing special, nothing new. I do have Wave 2 4800, which is our latest, greatest hyperlocating, singing, dancing box. The cool thing you can do with that is you can actually do, all Wave 2s, you can do what we call intelligent capture, where upon DNA Center detecting an anomaly, it will start a PCAP for you. Now, in the Wave 2, like the 2800s, 3800s, it captures the headers. The 4800 can do a full PCAP, including roaming. So as someone roams from AP to AP to AP, it'll feed you back one PCAP, which is pretty cool when you're trying to troubleshoot something pretty tricky. This is what I got. One of my coworkers used to be Advanced Services TAC, and he had a case open for 71 days. And what it was is whenever someone would make a phone call over a Wi-Fi phone, perfect, great, no problem. When they did the push to talk on the same phone, it was terrible. Couldn't figure it out. And there was nobody there. 3 hours, the closest person for that company was 3 hours away. So coordinating it, they had to train somebody on the software, have someone drive out there. They get out there, oh shoot, we got encryption turned on. So you got to turn off encryption on the wireless in order to start doing your packet sniffing. And then, oh shoot, we don't know what's going on in the data center. So they had to send another guy, another time, send them both back out again to the data center so they can capture both what's happening in the data center and what's happening with the phone. They're trying to do all this stuff and coordinate it and do it, all said and done, 71 days. What it came down to was the phone had a bug in it. It forgot to set the QoS, forgot to set the priority to voice. So when you did a phone call, it was platinum quality. When you did push to talk, it was best effort. That's all it was. There was just no way to know there was a bug in the phone. Now what we can do here, we can do it in about 10, we'll do it here in probably about 2 minutes. So I'm going to pull up the 4800.
And they figured out that bug because eventually they did get the packet capture.
Yeah,
right?
it took two guys, 2 laptops, 2 different locations, NTP synced, doing packet captures, getting the logs, sending them back to one person. They tore through the logs and finally found that packet problem. It was not an easy bug to find. So what we can do here is, so I can go into intelligent capture. I'll just show you some of the stuff it can do. We've got our client counts, channel utilization. We can go into frame errors, frame counts. We can get pretty darn deep into troubleshooting an AP's problem right off the bat. If you've got questions on Spectrum, you can run a Spectrum analysis. It takes a little bit to run, so I'm not going to run it now. But you can, from here, pull the Spectrum analysis and be able to see what's happening on all your frequencies. And then you can also, like I said, we can take a look at clients. So I'm going to go in here, take a look at the clients. So I'll just go ahead and do my laptop. And I'm going to do intelligent capture. And from here, so Brent's called up, I said, I'm having an issue, it's been driving you nuts, we need to troubleshoot this. First thing it does, it shows you where I am. It's hard to see, but you can see, and I can zoom in here a bit. First off the bat, shows you where I am. So you're not trying to, you don't have to go, okay, Brent, what building are you in? What floor are you in? Where are you at? What room are you in? No, it's just, okay, I already found you. Here you are. And now depending on the AP, it gives you different location quality. In this case, it's got me right on top of the AP, which is sitting right there. And then I have the option of doing start full packet capture. So I am right now getting a PCAP off of that AP, and it's going into the DNA center. I don't have to be on site, I don't have to be in the same city, but I'm getting the PCAP to troubleshoot some of these weirder issues. I can hit stop. And now it's giving me 2 PCAPs I can download. It gives me a wired one from what the AP is sending down the line, and it's giving me a wireless what the AP is receiving from the client. And because it's a 4800, it's giving me full data capture with all data payloads, everything. Then I can simply download it. And now I've got my PCAP live, no issues, no fuss, no muss. If I need to capture multiple sources, I can do that. and it's so easy, and you don't have to fight the system and fight the protocols and fight different locations. You can do it anywhere you have the system tied into. So it's a really, the hope and dream for all of us is we go less and less into PCAPs, and we go less and less into packet captures and all this stuff. But when you need to, you need to, and we've tried to make it much simpler to get those information. You can even set it up where when a certain MAC address comes online, it'll automatically start the PCAP for you. So when if a user says, hey, I'm having issues, you can say, great, I'll take your device, I'll put it in here, I'll set it to automatically record when you come online. So if they come online in 6 hours, it starts recording, and then the help desk can come in and hit download at their leisure. You know, and like I said, one big thing, it's not very often, but it'll also, if you on the same model AP, create one file no matter how much you roam. So rather than trying to stitch together what was that one we saw that had, how many APs did that person touch? 20? You know, you get one file rather than trying to stitch together 20 different PCAPs on troubleshooting things. So we've got sensor tests, we've got dashboards, we've got drill downs, we've got suggestions. Okay, I've been talking for a little bit here. Is there anything you guys have gone, okay, that's great, or I don't get why is this happening? Why would you want that? Okay, I'll keep going. So we've gone over kind of the network view, watching how the APs are. We've also gone over the clients, digging into clients and trying to work out where your issues are. So the last thing is application. So we don't have application running here solely because today we don't support the Meraki MX250s as a N-bar source of data. So I'm going to load up a lab version I've got internal to Cisco, just kind of show you how it works, how it's supposed to go. But if you had an ISR or in, I think, two releases from now, we'll be supporting AVC and more boxes like the WLCs and things like that. So that part's coming. Right now we ask for a router, but that requirement's going to go away quickly. 3850s even have AVC. You know, so it's going to be that problem is going to go away quickly. From that point of view, so the third piece is applications. So you think about today, how many people have 365? Skype, OneDrive, Box, yeah, Blackboard. I remember that when I was in college. Blackboard was a big one. I don't know what the education tools are now, but those are the ones that your users care about. They don't care if Facebook's having great performance. I mean, the clients might, but as a company, you don't care that Facebook's having great experience. You care that the apps you are paying for, the SaaS offerings, are up there. So what you can do is you can say, track my applications and do it for business relevant, irrelevant, or everything else. The fact of the matter is we can say secure shell is pretty important to me because I want to be able to take a look at some of my boxes. OWS, that's pretty important because that's my email for everything. That's how I communicate. And 365 for all of my box, PowerPoint, stuff like that. We're going to keep a score, and we can even go in here, and then we will score them for you. So in the sense that we can go in here, and just like we did with the network, just like we did with the clients, we're going to score its health. Help you dig it out and identify problem areas quickly and easily. Not, you're not going after looking for packet loss buried in a sea of numbers. It's saying, here's your health, start looking here, and it's going to show you why it gave you a low score. So as I mouse over, we've got some really bad packet loss, 3%, 2%. So if score of 4 gets you 3% packet loss and 4-second network latency, I think you're going to have some phone calls over those scores. The fact of the matter is 4-second latency on OWS, probably not the greatest. 37 packet loss, definitely going to be getting some calls on I'm clicking and going nowhere. So, and it doesn't have to just be overall 365. It can be this floor. So in this case, we're in the convention center floor. So you can say convention floor has a score of 1, but the other building over on the other side, the Crown Plaza, they've got a score of 9. So we can quickly go, it's not a global issue with 365, it's a problem with the building. You can really narrow down where your problems are very easily. And then like I said, so we can go in here, we can dig into some more things. We can see what's telling us this, how's it getting the information from it, where are we getting the information, and really be able to say, don't wait for the call. I mean, that's my whole motto here. I mean, if you take away anything, and frankly, I don't care if you use our product or somebody else's in general. The reality is, figure out in this next generation, how do you not wait for the call? How do you get proactive, right? I asked somebody, how do you do network changes? And they go, putty, copy and paste. And I go, how many switches do you have? 100. How many of those, how do you know that you've done those 100 right? Well, I don't. They go, we're pretty sure. Well, the way they figure out that they've done 100 switches right config updates is if no one calls, they've done them right. That's their methodology. Well, that's I'm not saying that's how most people do it, but we can do better, as far as making sure the experience is happier. And then, like I said, if we want to, we can go into and take a look here, business relevant. So Disney Web Portal, it's got 4% packet loss and 200 millisecond data loss. That's great. Now we know what people are doing on their free time. And we can keep a look. And and if once I've got my business relevant stuff happy, then I'll take a look at making sure that Disney Web Portal and Facebook are doing well. But I'm going to spend my time and my effort making sure those relevant ones have the good scores, and these get second tier, rather than trying to troubleshoot my internet slow, and then you figure out what they're trying to do is not business relevant. It's just kind of a little different way of thinking, and and we're able to do that because we're collecting so much data. The fact of the matter is we've got 14 days of records. We've got all this history, all this telemetry being recorded in live time. When John and I were looking this morning, making sure the network was up and running and happy, John could pull up everything I was showing live. The problem is, how often do you click on something, say, oh, we've got 85% utilization issues, or we've got high packet loss. By the time you go through and drill down where you need to troubleshoot next, the problem's gone. You need that history, that DVR, to be able to really effectively troubleshoot some of these more advanced things. So.
Can you pull up a client 360 page?
Oh, yep.
Just to go through that here where we have a little bit more data.
So nice thing is, make sure this lab's got what I want. Yep. Let's say you have a user Daphne calls you up, says, I've got an issue and I don't know what's going on. It's just terrible. So I can actually go in here because I'm tied in Active Directory. I can go ahead and click on search for Daphne, click on her, and bring up her user 360. Basically, it's going to give me all the information that this system has around her and everything she's authenticated on. So she actually has a lot of devices. She's got Cisco switch, laptop, iPad, PC, iPhone. She's a really technology savvy person. And I can scroll through here and go, okay, all these devices are actually sitting at 10s. What's your issue? So you can quickly, the theory here would be, if the lab was set up right, that you would have a bad device where you could say, look, rather than trying to figure out which of her devices, you can say, I see which device is wrong with you, which device you may be having issues with. But we'll just call it the iPad for right now. So I'm going to click on that. So I'm going to click on her laptop, because right now it's actually giving me a score of 10, but it has some issues. If I scroll down to the event viewer, she's having four-way key issues. She's having authentication issues. So this might have been what she was having problems with. Right? So you can kind of go back and take a look, and even though it doesn't give you all the answers, it gives you a good place to start talking to. And you also, on that note, know where she is, what she's doing. Here's a better one. So in this case, Daphne's PC looks pretty good. But if she says I was having issues, I can come back here and say, okay, what was going on? So the onboarding failed. So she was having issues. There's no question about it. She's not, she's right on. But I can go back and start looking through it. So I can start going, okay, she was on LA Corporate. And then right here, I can see it just changed. The SSID she was trying to get onto was top secret. And if she's got, look out here, we can probably start digging down into the fact of the matter is she was trying to get on the wrong SSID. And when she started getting back into corporate, she was good to go again. So she was having an issue. It was a real issue. There was no question about that. But we were able to say, here's the problem. You were trying to get on the wrong SSID. That's all there was to it. And then you can go through her devices. We can see where she was. She was in SM floor 1. We don't have to ask all these questions about where they are. When I started with Cisco about 2 years ago, I had an issue with a port at my desk. And I said, I've got an issue with my port on my desk. I'm in Carmel office. And they go, oh, which switch are you plugged into? I go, I don't know. And they go, can you find out? I said, well, it's in the lock, the IDF closet. I can't get in there. And they go, well, can you find out how to get in there so you can actually tell where the cable's plugged in? I'm like, I'm a Cisco IT guy. Yes, I can do that, but that shouldn't be my job, right? That's help desk asking me to dig into these things that are sometimes really hard for a client to answer. So that's kind of the goal here with this 360 view, is be able to pull up all the information you can so you can really start narrowing down how to help them. To me, that's a pretty cool thing. Like I said, that does require some way of knowing their username. Open Wi-Fi with no authentication or no WebAuth really puts a crimp on that. But if we had just put WebAuth on here today, we would be able to do the 360 view for all the users. The reality is my Icebox is fairly old, and I didn't trust my old Icebox to take a hit for 1,100 users. And I did dig into it, and it wouldn't have made it. Just from a passive mode I looked, it wouldn't have survived. So I'm glad we went that route. John, so John's a CCIE wireless. He's the one who set up the network, and he's been digging into it too. And this is his first time really seeing it in anger. In an 1,100 person environment, right? Labs are really great and easy to build with 8 to 15 clients. It's really hard to get 1,100 volunteers for your lab. Thank you, by the way. So this is 6:20 a.m. as people start coming in. These are our DHCP requests. And as you can see here, 2 seconds. We've got a few more than 10 seconds. And I'll bet you money that's just the fact they were walking by a DHCP, they were roaming so fast they didn't have time to grab it. They just barely latched on the AP and went moving. But if I'm getting 205 minutes, I have 251 onboards. 5 at 2 to 4 seconds, 1 at 4 to 6 seconds, and 1 still connected though at more than 10 seconds. I'm thinking I'm doing pretty good on my DHCP. Right? It really validates the fact our DHCP server, like you said, it's running on an MX250. It's holding perfectly fine. We are not starting to see spikes on how we're doing.
55, you can actually see an orange spike there at the top of the green at 8:55 a.m. And that's where the DHCP server was starting to have problems.
Yeah, we'd gone up to. So we were up to 191, 2 seconds, 47, 2 to 4. So it was starting to creep up there when everyone was wandering in. To your point, I don't know how else I would troubleshoot that without a packet capture. Or tearing through DHCP logs and coming up, feeding it into some graphing program or some tool to get that for you.
So that could indicate, and actually, if you add in authentication, if you're doing radius, this could actually tell you how long the radius server took to respond. So you can tell if your radius servers are slowing down the authentications as well. For a lot of schools, one radius server is enough, but a lot of schools are on the edge, but one isn't enough. And you don't go from 1 to 2, you go from 1 to 3, because you want to load balance. Once you load balance, the other 2 are actually serving your radius. So you would say, oh, well, my radius authentication times are going to 20 seconds. That's not acceptable. And I see, since now I know this radius, I just need to do a cluster of radius servers, and that'll resolve the problem.
John, this morning, John was commenting on this RSSI graph. The fact that it's showing that we're actually sitting pretty well. As he put it, we've got a nice bell curve. In a sense, we've got some APs that are, we got some APs that are great, but we've got about the right amount of APs as a whole. As a system, we're sitting pretty good on the AP count. We cut back the APs this year, or last year, I can't remember which.
We cut them
But in that case, he had no way of knowing last year how close to the edge he was. He knew he pulled him back. Did he put it at, oh, we were close to tripping over the edge, or was it perfectly safe still? How do you validate some of these design decisions? And then with a 3-day event, we've got no way of knowing. And schools are very similar in the sense that you've got people come in at 8 a.m., they slam your Wi-Fi, and then an hour later, they rearrange on you. So, you've got to be able, it's always changing and always adapting. It's a tricky thing with school. We had a discussion, we saw this client count per band that only 9% of the users were on 2.4. But we were seeing that other 5 gigahertz APs were overloaded. They were sitting at 80% utilization. And so we had this quick discussion. Oh, wow, that's really interesting information. Should we think about quickly opening up the 2.4 to more APs? We talked about it and said, no, the APs are holding, the client scores are good. We'll keep it as it is because putting more people on the 2.4 is going to cause more problems than it's worth. But we never would have had that discussion this morning if we hadn't been able to see some of this information. That's the key is it starts a lot of conversations, starts a lot of thoughtful processes when it's in a human readable form, not a bunch of scribbles.
It also brings up the conversation of, okay, so what options do we have if we want to improve the situation? Do we go in, are there better APs that might handle this a little better? Could we possibly add another AP with a 5 gigahertz radio in that room? Maybe we go to a different model AP at the 3800, we can enable both radios at 5 gigahertz. So you start, once you know what the problem is, you can start working on the solution, right? And so that's what we're going to get there.
Yeah, the number one AP this morning was actually this 4800 sitting here. And it didn't dawn on me until about 2 hours later. It's got an XOR radio, so it put them both into 5 gigahertz mode. So it had twice as many radios in this room as everybody else did. So of course we had more clients connecting up to it, right? But it's those kind of things where, hey, a 4800 can handle the load better than a 3700. Something to think about as you're doing your design and modifying. If you've got a room on edge, well, how about we just put a little different model that we can prove in other circumstances will handle the load better, rather than just tossing a whole nother AP in there. That 3700, 3702 can go somewhere else.
So this was billed as investigating the HECC wireless. Anything you guys want to investigate as we look at the HECC wireless? We've seen a lot.
Yep. Now we do have Umbrella sitting. We are running everybody through Umbrella for DNS requests. So that's kind of our firewall. Filtering. So that's helped a lot. But we were able to dug into this morning. We dug into client usage. Our number one client usage as of 9 a.m. was someone was playing World of Warcraft or something.
You're pulling that umbrella information into the dashboard.
In this case, that will be coming right now. That's separate. I just took a quick peek, but we're really keeping a lot of that extra stuff out. It doesn't interfere, but where's what I'm looking for? That integration point isn't there yet. So, but I guess my point was you can have these systems, and they don't interfere with each other. You don't have to go, oh, I've got a DNA center and it doesn't support Umbrella. No, you can still run your Umbrella. You can still run your AMP. You can still do your fire. Just because it doesn't support it today, we aren't going to be interfering with other stuff. You're okay with third-party solutions. I'm not saying this, but we are road mapping out ClearPath, right? As a third-party solution. And the fact that we are trying to make sure that this is as open of a system as we can do it, and try and make it as low impact, so fairly vendor neutral. That said, we haven't seen a lot of vendors say, oh yeah, we'll go with Cisco's open standard, but it's there, it's open. We've got other checkpoints, some other firewalls. We're seeing more and more people kind of come on board. You can even go as far as software management. If you've got 100 switches, you can say, I want to upgrade my 100 switches. It will feed it into ServiceNow. It will go through your service chain of who gets to approve the upgrade, the timelines, all that stuff. Once you do it all in ServiceNow, it feeds it back into DNA Center, and DNA Center will go and do your software updates and then give you a report on that. Gives you a lot of operational stability And ServiceNow is just the first one. I've got a slide somewhere. Again, I'm going no slides here. So probably 20, 25 different vendors I know of right now have plugged into DNA Center. Power monitoring for, making sure your PoE stuff turns off at night if you're not going to use it, all the way to asset tracking stuff. People are doing a lot of creative things, creating applications with all this data that's available to them. CMX gave the heat maps and the graphics. Again, I literally spent 0 time in CMX. I fired up the VM, gave it an IP address, and then all I did was tell DNA Center where it was, gave it a username and password, and I didn't touch CMX as a thing. I let DNA Center handle everything about it. So it really reduced the amount of time I spend on stuff like that.
Where does Prime fit in?
So this is the future of Prime. So what we're doing is basically, this is covering a lot of Prime functionality today. I would say where we're weak compared to Prime would be detailed reporting for people who have their reporting structure set up and they've got their perfect reports. Great, that's coming. And then the compliance modules are probably the 2 things that are missing in Prime primarily. They're being actively developed. We're developing towards full feature parity, and Prime Forward will be this product. What we've done as Prime renewals come around, under the new DNA Center, under the new DNA licensing on devices, we're including Prime on switching and wireless to make sure, so you don't have to say, oh shoot, I got to pick one or the other. We're just, you go with the new licensing, you're going to get Prime, period. Trying to make that an easier transition at leisure.
You already have Prime licenses.
There's a credit towards the new licenses. I'm trying to stay a little tech, but yeah, we can. There's definitely a path to making sure that we move correctly to the new system. So from a, where were we? You've obviously, it sounds like you've dealt with Prime. Prime was a great tool for managing stuff, but it wasn't the easiest to manage. It wasn't easy to keep running. And it wasn't the most intuitive. The goal here is to give you all the advantages Prime gave you, but do it in a 2-3 day learning time, rather than having to fight, and get it up and running. That's the goal. There is read-only access. You can give different permission levels into this. You can set up read-onlys, different account levels. So that's a real strong thing. So if you want someone to be able to go in, look at dashboards, but not click anything, you can completely set that. That's it sounds easy, but it's really nice to be able to do and say, look, your job is to make sure that, let me know if you've got problems. But I don't want you to be click on the button that says delete device.
I think you touched on it, might have been not following fast enough, but the whole Meraki cloud management integration.
So this does have Meraki.
I know you don't have the switches.
So you're right. I did not include Meraki into this. Again, from a time point of view, I in no way want to impact the event on something I hadn't tried on this scale. It's been done in production. We have an API link between DNA Center and the Meraki dashboard. Basically, you go in here. You come into the inventory, inventory, and then you can do an add, say Meraki dashboard, feed it the API key, and it will communicate with the Meraki dashboard and sync up and show you both your devices.
So you go in here, you're basically popping out to the dashboard.
Yep. Yep. And you're going to see more and more of, these API links. The goal here is, if you want to go in the dashboard and do it in that way, great. If you want to do it in here, great. Your choice, because we have an API link. Same way with our SD-WAN solution that runs on vManage. We're going to have an API link to that, where, we're not going to force any way of doing business, because everyone's got different ways of doing it. But those APIs, as software-defined paradigm, is going to allow you to make your choice where you want to do this. The end goal is ideally to be able to do everything in one place. We've already got too many dashboards as it is. I'll give one quick story just because I like telling it because it kind of puts a light on our face. So Cisco Live, as he mentioned, this year in Orlando, we were down for 29 minutes during the opening keynote this year. So I don't remember how many people are there. 12,000 users, something like that. It's 12,000. It was 12,000 users. You see the graph growing, and all of a sudden, poof, 0. 29 minutes, no users connected. And what it was there was a TCAM. Bad, yeah. So there was a TCAM issue. Well, what it was is they had been running assurance on the wireless. New product, big event, let's do assurance. The wired guys chose not to look at it. And if they had looked at the wireless assurance, it was saying, you've got a TCAM issue. TCAM issue. You've got it coming. You're running out of space. It's coming. It's here. Down goes the network. Oh, first of all, the reason I know this is the wireless guys love telling the story because it's a wired guy issue. But it told them what the problem was. So Cisco NOC took another 17 minutes to troubleshoot the problem, to figure out it was a TCAM issue. So if they had at any point in those 17 minutes looked in the DNA center, it would have told them where to go looking. And these are sharp Cisco guys. They know the system inside and out. It took them 17 minutes. And it took them another 12 minutes to get it back up and running. So they fixed it really quick. So the moral of the story is, because this is looking at so much information and processing it in such a human-readable format, it would have avoided the issue. And if they looked at it after the issue, it would have told them where the issue was, and would have solved either no issue, solved 30 minutes of downtime, or at least 17 minutes of the downtime. Could have been resolved if they just looked at it. Needless to say, it's now part of the wired guys' standard operating procedure now too. So I think it just shows running a network's not easy. The fact of the matter is there's so much stuff and so many things happening. How many pieces of information are coming in at you on a daily basis? And to keep an eye on all of it, it's pretty difficult, especially when you find a TCAM issue and a distribution layer switch buried somewhere at this entire Orlando Conference Center. It doesn't take much to make an impact, but this is be able to watch everything and give you the focus you need to change what really matters. That's my hope of what these systems will be doing. Taking less time finding issues and more time being able to fix the issues and move on, and under your more useful time.